yesterday, we talked about this. The square root of negative 1 was I. Does that sound familiar? Okay. So if I look at A, what's the square root of 16? Okay, so you tell me is 4. Is there a radical sign there still? Why not? It's a perfect square, and so the square root of 16 is positive. It's a perfect square. So when I take the square root, it's a 4. So if I rewrite this, it's really 4 times 4. That makes 16, right? And so when you have a pair here, when you take the pair out of the square root sign, it's just the one number. And so here's one way to think about this. I'm going to tell you a little story about it, okay? It's your favorite thing. You all love dating. You love your boys and girls. We love to date. So when you look at this, think of it like this. I have a pair of 4s. If you have a pair, they get to go on a date, so they get to come outside of the square root sign. And the square root goes away. Okay? So, let's look at the 48. The 48 is not a perfect square. So, I'm going to start 48, and I'm going to write it this way. And you're always going to start with a 2, a 3, a 5, or a 7. Yeah. So, I guess somebody at a younger grade calls this the birthday cake. I don't understand why it's the birthday cake. I'm just doing reverse division. Yeah. So, I'm going to start with the 2. And if I put 2 here, so 48 divided by 2 is 24. If I divide by 2 again, I get, if I divide by 2 again, 6. If I divide by 2 again, I get 3. And I get to stop because that's one of the numbers that's here. So now I want to know who gets to go on a date. These 2 get to go on a date, right? These 2 get to go on a date. And the poor 3 is a loser and he has to stay home. So, you have the 2 times 2 on the outside, and that's 4 times the square root of 3. So, I start with a 3 on the outside. I'm going to look at the 60. If I divide by 2, I get 30. If I divide by 2, I get 15. Can I divide by 2 again? So what am I going to switch to? 3 or 5, it doesn't matter. Because I get a 5 right here, and so I get to stop. So who gets to go on the date? 2. So one of the 2's gets to come outside the square root. And the 3 and the 5 are left. They don't have dates, so they had to stay underneath the square root sign. So 3 times 2 gives me 6. 3 times 5 gives me 15. It does, but it also, this one doesn't have a partner, and this one doesn't have a partner. So there's 3 times 5 left over. Okay? So if I look at B, I have negative square root of 49. So this is, right. This is the square root of negative 1 times the square root of 49. And we said 49 is a perfect square, so that's 7i. But 75 is not a perfect square. So if I divide by 3, I get 25. Can I divide by 3 again? I can do 5. So who has a partner? The 5 has a partner, So the 5 can go outside the square root sign. I have negative square root of 1, and what's that? I. And the 3 stays underneath the square root sign. The I is always on the outside of the square root. Always. Because it's negative under here. So that's like the negative square root of 1 times 75. Okay? Okay, you all try F. So when I break the 32 apart, I get 16. So I have a 4 here already. So I have 4. What's the square root of negative 1? I. So I have a pair here, so this is times 2. I have a pair here, that's times 2. And this 2 didn't have a partner, so it stays under the square root sign. So 4 times 2 is 8, times 2 is 16, I times the square root of 2. So any questions there before I go on? Yes. Right. So this 4 came from right here. This 2 came from that one. And this 2 came from that one. And then this was the leftover one. Okay, what if I would have had this? This one. If that's a problem, what would I do? Why can't I? What's the square root of 16? What's 3 times 4? So it's a perfect square. You just take the answer and multiply by what's in front. Okay? All right. So let's say I have this. If I have x squared, that means I have 2 x's underneath the square root sign. So these 2 can come outside the square root sign, and they're just 1x. So if I had 4 x's, how many would come out? So I'd have x squared. So what I'm really doing is I'm taking this exponent, the 4, and I'm dividing by 2 because you have pairs, right? So if I have x to the 12th, how many pairs do I bring out? 6. 12 divided by 2 is 6 every day. So x to the 8th, how many pairs? So x to the 4th. So if I have 3 x's, I get 1 pair, but one of the x's has to stay under the square root, right? So I'm going to take 1 out and leave 1 in. So if I had x to the 5th, I'd have 2 coming out, and 1 has to stay in, right? So here's the pattern. So you take your exponent, the odd exponent, whatever's the closest even, so x to the 5th, the closest even is 4. 4 divided by 2 is 2, with 1 left over. Because that is x to the 5th, baby. And that's what I just said. I find it's not. So you find the closest even exponent, which is x to the 4th, divide by 2, and you have 1 left over. Okay, so x to the 11th. What's the closest even exponent? 10. So 10 divided by 2 is x to the 5th times the square root of x. For C. So the closest to 9 is 8. 8 divided by 2 is and 1 left over. Yes or no? Oh, yes, I'm sorry.
Thanks, Ed.
Okay, so I have x to the second. The second divided by 2 means it's going to be just the x on the outside, and we have to simplify the 12. So if I divide by 2, that gives me 2 and 3. So I have a pair of 2's. Right, so I get 2x times the square root of 3.